All right, kiddos, let's keep going. Moving back into question number 6. It says, Alan conducted a survey in his first period class to determine student preferences between band instruments. Out of 20 students, 6 like to play the drums. There are 80 students in the band. Based on the survey, how many students in the band like to play the drums? This question is about taking information given to you from a sample space and making predictions based off of that sample. So let's read the question again and make sure we understand what information we are given. It says, Alan conducted a survey in his first period class to determine student preferences between band instruments. Out of 20 students, 6 like to play the drums. There are 80 students in the band. Based on the survey, how many students in the band like to play the drums? So the first thing that I'm going to do is I'm going to identify the first piece of numerical information that they give me, which is that out of 20 students, 6 like to play the drums. I could write that as a fraction, right? So I could compare the number of kids who like drums or who like to play the drums. I'm just going to keep it short and sweet. I'm going to compare the number of kids who like the drums to the total number asked. Okay, so in this particular fraction, it would be 6 like to play the drums out of the 20 kids asked. Using this fraction, based off of this information, they want us to predict how many students want to play the drums if the group were 80 instead of 20. So here's how I would set that up. I would first start by creating a new fraction. My denominator would represent the total number asked, which would be my 80. And so my unknown piece of information would be the numerator, which would be the number of kids who like the drums in the larger group, okay? And so I could solve this like I've been doing some of these other problems. I could use cross products, but I think the easier way in this particular case is to figure out how do I get from 20 to 80, which is just the same as figuring out how to get from 2 to 8. And to get from 2 to 8, I times it by 4. So 20 times 4 is 80. And whatever I do to the bottom, I'm going to do to the top. And 6 times 4 is 24. Right, so that means if this group were a group of 80 students, 24 of them would prefer to play the drums. The correct answer is B, 24. Now remember, guys, another way to approach this problem would be to work backwards, okay? So if this process right here is a little tricky to you, what you could do is start out with your original fraction of 6 over 20, and then say, okay, well, my answer choice for A was 18. Is 18 over 80 equal to or the same as 6 over 20? Okay, how could I figure that out? I could do cross products. I could do 80 times 6 and see if it's equal to 20 times 18. All right, and if I did the math on that, it will not be equal. 80 times 6 is 480. And 20 times 18, I believe, is 360, but let me double check that. 20 times 18 is 360. So these, you can see, are not equal to each other. So therefore, that means that these two fractions are not equal. And so the sample space and the actual population would not match. And I would continue using a different numerator. Instead of 18, I'd go through my list and maybe I try 24 next until I got 2 answers that were equivalent to each other. Okay, pause the video and take down what notes you want. I'm going to move on to the next question. Question number 7 on the test says, Brooklyn and Paolo are running for 7th grade class president. 4 kids each polled 30 different students to predict the winner of the election. The poll results are shown below. So in this table, you can see that it talks about the election poll results. You can see that the 4 different students are listed here and that they each polled 30 different students. Some of those students would have voted for Brooklyn, and some of those students would have voted for Paulo. So student number one's poll results should add up to give me 30 different students that they asked. 14 plus 16 does equal 30. All right, and you can go through the rest of the chart and notice that all of these row totals are going to be 30. That's because each one of these individual students here pulled a total of 30 people. Okay, so based off that chart, it's going to give us a next step, another question. The next question says a total of 400 students will vote in the election. What is the range in the number of votes for Brooklyn predicted by these 4 polls? Okay, so here is how I would approach this problem. What I would first do is I would try to figure out how many votes Brooklyn was receiving in my sample space. Okay, so the first thing that I would do is I would take maybe the first student's report or the results, and I would say out of the 30 total votes, right, because 14 plus 16 is 30, Brooklyn received 14 of them. Right, and then out of this 30 total votes, let's write that a little bit more clearly. So she received 14 out of 30 for the first. For the second, she received 18 out of 30. For the third, she received 19 out of 30. And for the fourth, she received 12 out of 30. All right. At this point, what we could do is we could say that we have a total of how many students polled. All right, let's try to figure out how many students were polled, which means we're just asked a question. How many students were polled altogether? All right, so how could I figure that out? Well, this this student polled 30, and this student polled 30, and so on. So I could do 30 times 4. And that would give me my total number of students that were polled. We call that my sample space, right? So 3 times 4 is 12. So 30 times 4 is 120. All right, so right now, all I have is that my total number of students polled is 120. And out of that 120, the total number of students that were planning on voting for Brooklyn, I could find by adding together all of those numbers in that column that represents the number of students planning to vote for Brooklyn. So I could take the 14 plus the 18 plus the 19 plus the 12, and I could add that all together. And that would give me a total number of students planning on voting for Brooklyn. So we're going to go ahead and add this together. I'm going to keep it as simple as I can. 8 plus 2 is 10. 10 plus 9 is 19. And 19 plus 4 is 23. Carry the 2. 2 plus 1 is 3, plus 1 is 4, plus 1 is 5, plus 1 is 6. So I've got 63. Okay, so what that tells me is that I have 63 out of 100 students that voted for Brooklyn. So up here, if I'm creating this fraction, my denominator is the total number of students polled. My numerator is going to be the number voting for Brooklyn. Okay, so that's the first step. I guess that kind of took me a little while to talk through the information and get myself to step number 1. So let's be clear then, for our notes, step number 1 is going to be to create a fraction that represents the sample space. Okay, so again, just to recap, just to kind of go back to the beginning and talk about what I did. I know that each one of these 4 students interviewed 30 people each. So I use that 4 different students and the 30 students that they each interviewed, I multiplied those numbers together to give me the total number of students polled. That's called my sample space. I then looked at the target question. It said, what is the range of number of votes for Brooklyn? Because we were looking for votes for Brooklyn, I looked in the table and I found which column represented the votes for Brooklyn, and that was this left side of the table. So to get a total number of votes for Brooklyn, I added all of those values together. Okay, so 63 over 120 represents the fraction of students who were voting for Brooklyn out of the total number of students in the sample space. All right, so now I'm going to use that information of 63 over 120 to help me predict what's going to happen in the entire population. So I'm going to clean some of this up. Again, pause if you need to, so I don't erase the important stuff. And now what I'm going to do is I'm going to use this new piece of information that says that I have a total of 400 students. Okay, so total is going to go on the bottom. So in my new fraction that I create, I'm going to write 400 as my denominator. All right, and my numerator, I don't know. Okay, so I am going to try to figure out how to either get from 120 to 400. And because I don't know a number that I can multiply 12 by to give me 40, I'm going to do it the other way. I'm going to use cross products. So this is the first time that you're going to see me use cross products and solve an equation. We did learn this year, so hopefully this isn't too much of a stretch for you. Okay, so the first thing I'm going to do is I'm going to cross multiply, which means I'm going to do 120 times x, and that's the same as 400 times 63. Now remember, it doesn't matter the order that you multiply. I could do 63 times 400. I'm going to get the same thing. All right, so I'm going to do 400 times 63, and that gives me 25,200. Okay, and I've got 120x on the other side. So all I did was I cross multiplied, I used cross products. I then simplified or multiplied these two numbers together. Now the last step in order to get my variable x all by itself is to get rid of this 120. And because 120 is squished right next to x, it means it's being multiplied. The opposite is division. So I'm going to divide both sides by 120. And I get whatever I get. And I get that x equals 210. Okay, so what this number is telling me is the estimated number, or I guess I shouldn't use estimated because I didn't really estimate it. I predicted it. This would be called the predicted number of votes for Brooklyn out of the total number of people voting. And in this case, that was 400. All right, so then it says, what is the range and number of votes for Brooklyn predicted by these polls? This doesn't give me a range, it gives me an exact number. Okay, so this is telling me that there should be exactly 210 votes for Brooklyn, and 210 would fall in between 160 and 254. So I feel confident in answering answer choice C. Now, 7th graders, there is another strategy to this. Okay, the other strategy to this, actually, I'm going to tell you, if this made sense to you, you're going to pause the video and you're going to copy down everything you see on this screen. If this is a little bit hard for you to understand, I'm going to show you a different way. All right, so the other way that we could look at this problem, and again, if you already made sense of it one way and you don't want to hear it a second way, fast forward the video until I get to question number 8. All right, so the other way that I could look at this is to say, I'm trying to find a range of numbers for the number of votes that Brooklyn could get. So I really want to focus on this column of the chart. And I want to see which one of these numbers is the lowest number of votes that they predicted Brooklyn to get. Well, the smallest number here is 12. All right, and that was out of 30 total votes. So I could have, instead of taking all of the votes together, all 120 of the votes together, I could have just picked the smallest number of votes that Brooklyn got out of 30, and that was 12. So I could have written that fraction as 12 over 30, right? And I could have tried to figure out how much that would have been out of the 400 total students. So a similar idea, but this is what would have given me the range. So watch how I solved this one. So if there were 12 out of 30, that would have meant, I don't know how many out of 400. To get from 330, to 400, I'm not exactly sure what to do. So instead, I'm going to use cross products. I'm going to call this x, right? I'm going to cross multiply. I'm going to do 30 times x, which is 30x. And then I'm going to do, well, 400 times 12, which is whatever it is. And then I would multiply 400 times 12, which is going to give me 48,000. And then I would try to solve this equation by dividing both sides by 30. And I would get x equals 160. Okay, so I would take 48,000 and divide it by 30, and I would get 160. Okay, what this number represents, what this 160 represents is the total number of votes that we would predict Brooklyn to get out of a 400-person election, right? 400 people vote. 160 of those votes would have gone to Brooklyn. And so this number right here is going to represent the low end of the range of votes she could get. Right? It's the low end because I picked the lowest number of students planning to vote for Brooklyn as my numerator of that fraction. So 160 would be the low end, and you see that right here on answer choice C. And then I could just make sure that I did that right for the high end for 254. So the other step that I would do then is I would look back into my table and find out which number of votes for Brooklyn was the highest, and that would have been 19. And so I would have done the same exact process all over again, except instead of using 12 over 30, I would have used 19 over 30. That's the highest number of predicted votes that she would have gotten. And then I would have set that equal to 400, and I would have cross multiplied and solved just like I did before. So I do 30x equals 400 times 19. I don't know what 400 times 19 is, so I'd use my calculator. And I get 7,600. Divide both sides by 30. Wow, I did math bad on the last one. And I get x equals whatever I get. 7,600 divided by 30 gives me a crazy decimal. It gives me 253.3 repeating, all right? But remember, this represents a number of people voting. So this answer, we can't just leave as 253.3 repeating people. We can't have a third of a person. So I would say that's about 253 people. Okay, and so this 253 people out of the 400 people surveyed would represent the high end. All right, it would represent the high end of number of votes that she would receive. Okay, and so that's why it's just a little bit off of 254. It's because it was the 0.3 repeating. It still proves that answer C is correct. Now, ladies and gents, as in every single day in math, we all make mistakes. I did that right here. I'm going to go ahead and correct my mistake so that you have it properly down in your notes. 400 times 12 is not 48,000, it's 4,800. I apologize. Then when you divide it by 30, you do in fact get 160. Okay, so that was the second way to approach this problem. If you like that way better, go ahead and copy that down, take down all the notes you need, pause the video. I'm going to move on to the next question. All right, question number 8. Each student in Mr. Henry's class was assigned a random group of 12 seventh graders. They asked everyone in each group the following question: do you prefer grape or strawberry jelly? The results of some of the students' findings are shown below. Stephen's group said 4 people liked grape better and 8 liked strawberry better. Evan's group said 5 people liked grape better and 7 liked strawberry better. Talia's group said 3 liked grape and 9 liked strawberry. And Vivica's group said 2 liked grape and 10 liked strawberry. When the class combined all of the results, they found that 70 seventh graders preferred grape jelly and 120 preferred strawberry jelly. Which students' results were closest to the class results? So here is what we know. These are what we call the student results. This is what we call the class results. Oops. And remember, guys, what we're going to do is we're going to draw some comparisons and predictions. So we're going to start by creating some fractions, okay? So we are going to see which students' predictions or which students' surveys are closest to what the class's survey found out. So here's what I'm going to do. I'm going to start by creating my main fraction. My main fraction is going to compare the number of kids who preferred grape to jelly. Oh, that's silly. Grape to strawberry. Okay, I'm going to compare grape to strawberry. So in the class results, I have 70 kids who preferred grape and 120 kids who preferred strawberry. All right, now what I'm trying to figure out is which one of these 4 students, Stephen, Evan, Talia, or Vivica's fraction is the same or as close as possible. Okay, they're not going to be exact, but it says which students' results were closest to. So unfortunately, unless I get an exact match, I'm going to have to test all 4 students. So watch how I do this. I'm going to choose to color code. You do not have to. All right, I'm going to call Stephen's fraction red. All right, so I'm going to underline Stephen in red. He had 4 grape to 8 strawberry. Excuse me. All right, I'm going to call Evan's group orange. And Evan had 5 grape to 7 strawberry. Talia is going to be pink. And she had 3 grape to 9 strawberry. And finally, I'm going to have Vivica be blue. And Vivica is 2 grape to 10 strawberry. All right. So what I could do is, if I'm pretty decent at math, I can look at this original fraction and say, what's that close to? What is this really meaning, 70 out of 120? And maybe I would come to the conclusion that 60 out of 120 is half. Right? 60 out of 120 is 1/2. And 70 out of 120 is a little bit bigger than half. That's just something to maybe float around in my head because I'm looking for something that's close to half. And that might help me. Like, I know, for those of you who are strong in math, I know 2/10 is nowhere near close to half. 5/10 is close to half. So I know there's no way that Vivica's results were closest to the class results. So I wouldn't even have to do any math with this last fraction. For those of you who are really good at math, you might be able to answer this question right off the bat. You might be able to pick which student you think is close to half. But what we're going to do is we're going to be even more specific. And so what I'm going to choose to do, I could find common denominators, I could find equivalent fractions, I could do cross products, I could do all sorts of things. But in my mind, The fastest way to come up with this answer is to convert these all to decimal. Because all I need to do to convert these to decimal is have a calculator. All right, so I'm going to convert all of these fractions that I've just written to decimal form, and then I'm going to see which one is closest to 70 over 120's decimal. All right, so I'm going to start by doing 70 divided by 120. All right, and you can see that I get this crazy decimal 0.583 repeating, right? So this gives me 0.583 repeating. That's my target. I want one of these red, orange, pink, or blue fractions to be as close to that number as possible. So I'm going to go through and do the rest of these divisions. 4 divided by 8 is 0.5. 5 divided by 7 is 0.714, blah, blah, blah. I don't need to write down the whole thing. I'll explain that in a minute. Pink, 3 divided by 9 is 0.333333 repeating. And 2 divided by 10 is 0.2. All right, so you take a minute, you use your calculator, you get all the decimal representations, and your target is to try and figure out which one is closest to 0.583, right? This, in my mind, is about 58 cents, right? The first 2 digits after a decimal point mean money. I could use that idea to help me figure out which one's closest. Notice that after the 5, there is no digit here, so I could add in an invisible 0. So the red is about 50 cents, is actually exactly 50 cents. The orange is about 71 cents. And again, we're not talking money. I'm just using that to help my brain figure out what I'm looking at. The pink is about 33 cents. And blue, because it's missing a digit, I'm going to add in that invisible 0 at the end. So this is exactly 20 cents. All right, so what I could do now is figure out which one of these, red, orange, pink, or blue, is closest to 58 cents, and that would be red. All right, these are the 2 closest. So therefore, red, Stephen's group, his results were closest to the class results. So Stephen is the correct answer. Okay, go ahead and copy this down. Pause the video.